Have you ever wondered if the secret to eternal youth could be hiding in your dinner plate? It sounds like a page out of a fairy tale, but researchers at Penn State's College of Health and Human Development have been investigating just that. They wanted to understand how calorie restriction, that is, eating less, affects our telomeres, the protective caps at the ends of our chromosomes. The journey of discovery began with a 2-year trial on caloric restriction in humans. The researchers found something unexpected. Those who reduced their calorie intake lost telomeres at different rates than those who didn't, despite both groups ending the study with nearly the same telomere length. This was surprising because calorie restriction has been found to promote longer life in numerous species, from yeast to monkeys. Telomeres are fascinating. Every time our cells replicate, some telomeres are lost. As a result, the overall length of the cell's telomeres becomes shorter. When cells replicate enough times, these protective caps completely dissipate, leaving the genetic information in the chromosome vulnerable to damage. This prevents the cell from reproducing or functioning properly. So, a cell with longer telomeres is functionally younger than a cell with short telomeres. This means that two people of the same chronological age could have different biological ages depending on the length of their telomeres. Factors such as aging, stress, illness, genetics, and diet can all influence how often cells replicate and how much length the telomeres retain. This was the basis for the researchers' investigation into the effect of caloric restriction on telomere length. The story took another twist when the research team discovered that when a person's cells consume less energy due to caloric restriction, there are fewer waste products and the cell does not break down as quickly. This could be one way caloric restriction may slow aging in humans. The researchers tested the telomere length of 175 participants at the beginning, 1 year in, and at the end of the 2-year study. They found that during the first year, participants who were restricting caloric intake lost weight and lost telomeres more rapidly than the control group. But during the second year, these participants lost telomeres more slowly than the control group. So, what does this mean for human aging? Well, it's a bit of a paradox. On one hand, caloric restriction initially accelerates telomere loss, which could speed up cellular aging. On the other hand, over time, caloric restriction slows down this loss, potentially slowing down aging. It's a complex puzzle that researchers are still trying to piece together. But one thing is clear: the secret to a long life might just be on our dinner plates.